Hello friends, in this video lecture we'll see one of the most popular 8051 microcontroller. Before looking into the architecture of 8051, let us see let us see what is a controller is. The major difference between the processor and controller is the processor, it doesn't have any internal memory like a ROM or ROM memory, and also it doesn't have IO ports for connecting the number of IO devices, input output devices to the system. All these they can be found in a controller. That is, if you look into a controller you have a processor, you have a memory, that is RAM and ROM memory, and you'll have IO ports, and also you'll have some additional features like timers. So they all can be found in a single chip. So sometimes, so this microcontroller, it can also be called as a system on a chip or a computer on a chip. So as the controller have everything in a single chip, that is the timers and IO ports, and then memories along with the processor in a single chip. So it can also be called as a system on chip or a computer on chip. These microcontrollers, they are very fast, comparatively fast when compared to the processors, as we know that due to the reduce of the external accessing in the controllers, you can find these controllers in several applications, like you can find it in medical applications or communication or instrumentation or control applications. So you can find these controller in different application areas. So now if you look at this Intel MCS 51 series microcontrollers, so here we have shown some MCS 51 family microcontrollers. So I have different MCS family microcontrollers: 8XC51, C52, C51FA, C51RA, C51FB, RB, FCRC, and RD. So different microcontrollers are shown, and their ROM sizes are also noted here. That is, for 8XC51 the ROM size is 4 KB, and for the next version C52 or 51FA the ROM size is 8 KB. So likewise we have different memory sizes: 16 KB for FBRB, 32 KB for FCRC, 64 KB for RD. So the ROM size, the ROM memory that is used to store the programs for the microcontroller. And some other features of the 8051 family are also shown here. For example, if you take a controller of 8051 family, that is 8031 controller, that size of the data bus is 8 bits, and the RAM capacity is 128 bytes, and the ROM capacity is nil. That means the 8031 controller has the data bus of 8 bits width, and the RAM capacity is 128 bytes. That is for data processing, it is available, 128 bytes are available in 8031, whereas for program storage, it doesn't have any internal memory for program storage. So external memory need to be connected to the 8031. So through external memory access, you can run the programs on the 8031. That is for 8031, and for 8051 it is also 8-bit data bus. The size of the data bus is 8 bits, and the RAM capacity is 128, and ROM capacity is 4 KB. That is in 8051 you can have 128 bytes of data processing capability, and 4 KB for a program storage. So likewise for 8751H and 8052AH and 8752BH, different device numbers and the RAM capacities and ROM sizes are shown here. This is about Intel MC51 series microcontrollers. Now let us look at the architecture or a block diagram of the 8051 controller. So in 8051 controller we have internal memories, RAM and ROM. So we know that the RAM memory, it is used for data processing. So in this 8051 controller, the size of RAM is 128 bytes. So you have 128 bytes of RAM memory for processing the data, and the address for the RAM is provided. The mechanism for generating the address for the RAM is done through the RAM address register. So RAM address register will provide the address for the RAM, and you can do both read and write operations on the RAM. So it's a bidirectional data access. And when it comes to the ROM, so only read operations are performed on the ROM. So it is unidirectional, and ROM also having a program address register, or it is also called as a ROM address register, program address register. So that provides the address mechanism for the ROM. So that is the RAM and ROM memories. And we also have the DPTR. DPTR is a data pointer. So data pointer is a 16-bit register. Data pointer DPTR is a 16-bit register. So in this we also have two separate 8-bit registers, that is DPH and DPL. DPH is the data pointer higher register, and DPL is the data pointer lower register. So you can access 8 bits of this DPTR, or you can access the 16 bits of the DPTR. So DPTR is used to provide the addresses for the external RAM memory. So for the RAM, external RAM memory, external RAM access, DPTR is used to provide the addresses for the data, RAM addresses for the data. And in 8051 controller, in addition to the memories, it also have the ports. So it has 4 ports in 8051: port 0, port 2, port 1, and port 3. So port 0, port 1, port 2, and port 3. So in total it has 4 ports, and you can see that the size of the each port is 8 bits, P0.0 to 0.7 and P2.0 to 2.7. So 0.0 to 0.7 it has 8 bits, and P2.0 to 2.7 also it has 8 bits. Similarly 1.0 to 1.7 and 3.0 to 3.7. So each port is having 8 IO pins. So in total you will get 32 IO pins for the 4 ports, and each port is provided with a latch for storing the data. So you have a port latch, port 0 latch, and port 1 latch, port 2 latch, port 3 latch. So for each port you are having a latch for storing the data, and you also have port drivers. For each port separately you have port drivers for port 0 and port 1, port 3, and port 4. So that is the 8051 is having 4 different ports, so that you can connect the IO devices to these ports. IO operations are performed through these ports with the pins, cap pins. That is, each port is having 8 pins capability. And now let us look at the accumulator register and a B register. So accumulator register is used to store the results or accumulate the results. So ALU, have ALU in 8051. The size of the ALU is 8 bit. So it performs operations on 8 bit data, like it can add to 8 bit numbers, or it can subtract to 8 bit numbers. It performs arithmetic and logical operations. ALU unit perform arithmetic logical operations on 8 bit data. The size of the ALU is 8 bit. So 8051 is also an 8 bit controller. So once the ALU performs any operations, the result accumulated in the ALU, that is the results gets accumulated in the ACC, which is accumulator register. And also we have another register of B register. So this B register is used is like just like the accumulator. It is also used in multiplication and division operations. This B register can also be used as general purpose registers. So this B register is having an address in 8051. Similarly, accumulator is also having an address in 8051, and also the ports, port 0, port 2, and the RAM memory, this port 0 and port 2, they are also having the addresses in the 8051. And then it has two temporary registers, TMP2 and TMP1. So these temporary registers, they are not accessible by the user. They are for the internal purpose of the controller. The programmer cannot use these registers TMP1 and TMP2. So the data is transferred to the ALU through the temporary registers TMP1 and TMP2. They are internally used by the controller. Programmer is having no access to these registers. And once some operations are performed in the ALU, then it sets the corresponding flags in the PSW. So PSW is the program status word, also called as a flag register in 8086 or 8085 processor. It's called as a flag register. So that is, it contains this PSW, program status word. Okay, it contains a set of flags, so that affects after executing an instruction in the ALU. Like if you perform an addition operation and if the result is 0, then 0 flag gets affected in the PSW, and if there is a carry, then the carry flag gets affected in the ALU. Carry flag gets affected in the PSW. Or else if there is a parity in the result, then PSW gets affected. So based on the result of the ALU, some of the flags are affected in the PSW. So PSW is a program status word that gives the status of the instruction after executing the instruction. So the size of PSW is 8-bit in 8051. So we'll discuss in detail about the PSW later. And then it has a stack pointer. So the size of the stack pointer is 8-bit. That is used to point the address of the stack memory. So the stack memory is available in the RAM itself. So some portion of the RAM is used for the stack memory. That is, stack is allotted in the RAM itself. So stack is generally used to store the stack data that occurs, stack data that occurs in interrupts. So when interrupts happens, then the data is temporarily stored, the stack data is temporarily stored in the stack. So that stack memory is pointed by the stack pointer. That is, stack pointer is used to hold the address of the stack memory. So stack memory address is pointed by the stack pointer. The stack pointer operates differently compared to the other Intel processors. That is, 8051 stack is different compared to the other processor stacks. And it also have interrupts, separate blocks for interrupt and serial port and then timer. So it has separate interrupt capability. So it has interrupt capability. So interrupt can be controlled with the help of separate registers, and it has a serial port for transferring the data serially from 8051 to other serial devices, or it also receives the serial data from other devices. So it also have a serial registers for control of the serial ports, and also have two timers, two 16-bit timers. Those timers can also be configured and controlled with the help of the timer registers. So we'll discuss about the timers and serial data transfer in our other video lectures. And now in this video lecture, you'll see instruction register and timing control unit. So if you look at the timing and control unit and instruction register, so this timing and control unit and instruction register is used to hold the operational code of the instruction. That is, the instruction is decoded, and the operational code is stored in the instruction register, and then it is given to the timing and control unit for generating the timing and control signals for the execution of the instruction. The timing and control unit also have 4 control signals shown here. One is the reset signal. Reset is used to reset the 8051 controller. So you need to apply the 2 mission cycles, minimum 2 or more mission cycles should be the reset signal should be applied minimum for 2 or more mission cycles, then only the reset works. And it also has 3 other control pins: external access and address latch enable and program store enable. So this external access, address latch enable and program store enable, they are used for external access. That is we have internal memory, ROM and RAM, so you can also interface the external memory to the processor, to the controller, so that can be for the accessing of that external memory can be done through these control pins. EA, so EA is the external access pin, it's an active low pin. So when EA is 0, that means the user wants to access the program from the external memory. In case if EA is 1, that means the user wants to access the program in the internal memory. So it depends upon the EA bar, external access pin. And address latch enable AL indicates the proper valid address on the address lines, and this is used only in external access memory, accessing the program from the external memory. And program store enable, PSEN, is a program store enable, so which indicates that data read from the external memory. So all these 3 control pins, they are used in external accessing, external memory access. And it also has a oscillator. So oscillator with the 2 crystal oscillator pins, through the 2 crystal oscillator pins it generates the oscillations, that is the clock frequency. It generates the clock. The clock frequency range is 12 megahertz to 16 megahertz for the 8051 controllers. So that clock frequency is generated by the oscillator. So amplifier with feedback connected with the 2 pins XTAL1 and XTAL2 generates the clock signal at different frequencies, that is 12 megahertz to 16 megahertz clock for the 8051 microcontrollers. And these ports, already we discussed about the ports. And now what we left with is the PC program counter. So program counter is used to hold the address of the instruction to be executed. So program counter is incremented with the help of PC incrementer after executing the instruction. That is, program counter is used to track the execution of the instructions. So this is about 8051 microcontroller block diagram. So mainly, if you look at the features of the 8051 controller, it's an 8-bit CPU. So the size of the ALU is 8-bit. So you can do operations on 8-bit data. And the size of the on-chip program memory is 4 KB, that is the size of the ROM. So size of the ROM is 4 KB ROM. And on-chip data, for data processing, we have a RAM of size 128 bytes. And we have a serial port, full duplex serial port. So we have a full duplex serial port for transferring the data serially. And we also have 4 ports of 8-bit each. So we have port 0, port 1, port 2 and port 3. So you have 4 ports for connecting IO devices. The size of each port is 8 bits. And you have 2 16-bit timers, and that is 2 16-bit timers are used. And it also has on-chip clock oscillator. And the size of the data bus is 8 bits and size of the address bus is 16-bit. So by using 8-bit data bus, you can transmit or receive 8 bits of data. By using a 16-bit address bus, you can address to 64 KB memory, that is 2 power 16 KB of memory can be addressed by using the 16-bit address bus. So if you look at the memory organization for the 8051 controller, so you have 2 memories. One is the program memory, another one is the data memory. So program memory, internally you have 4 KB memory of ROM. So in additional to the 4 KB memory, you can also have 64 KB of ROM, and that is external memory. That is we have a 16-bit address bus. So by using a 16-bit address bus, we can address 64 KB of ROM memory. So external, if you want, you can access total 64 KB of external memory or 4 KB of internal memory. If you want to access both internal and external, internal 4 KB can be accessed and external 60 KB can be accessed. Similarly, for data memory, for RAM also you can have external memory of 64 KB RAM and 8051 controller, and also the internal you have a 128 bytes. So internally you have the RAM of size 128 bytes. So if you want, you can use the internal 128 bytes of RAM, or you can access external 64 KB of